So, hey guys, today we are going to discuss this weekly contest 373, and we are going to start with the question first. Okay, so the questions is says that we have given an matrix, okay, and what we have to do, we have to perform few operations, and we have to, after performing few operation, we have to see that the matrix we got after performing operation is equal to the matrix we have initially, right? Let's we have this is our matrix, this is our first matrix, right? And after performing few operations we got this matrix. Is this is identical to it? Yeah, it is identical, so we have given true, so we have to given a true or false. And what are the operations? We have to do a cyclic shift on a single operation. We have to do a cyclic shift right side. If I am at in the odd index, and I have to do and a left cyclic shift if I am currently at an index, even indexed. Okay, let's see how what I am saying. Let's say this is the matrix, right? And if I am saying that for odd index, what I have to do for odd index, what we have to do, we have to perform, uh, I guess, left shift. For odd index, we have to perform a right shift, and for even index, we have to perform a left shift. So left. So let's say um, this is our zeroth index. So this is a even index. So we have to perform a left shift. We left shift means that element here will come here. The element present here will come here, and the element present here goes to the last. Okay. And what does mean the right shift? Right shift means the element present here come here, and the element present here will go here, and the element present here will come here. So this is the right shift and this is the left shift. I hope this is clear to you. And we have to perform this operation exactly k times, and k is given to us. Okay, we have to perform this exactly k times, and k is given to us. And we have to see that after performing these operations, our solution is, our matrix is identical to previous or not, right? Let's see what is happening. This is the matrix. Okay, 1 2 1 2, right? After performing left shift, left shift, it will become 2 1 2 1, right? Okay, after performing again left shift, it will become 1 2 1 2. Okay, okay. So yeah, this, and let's say 5 4 5 4. And let's say if I perform a right shift here, it will become 4 5 4 5. And again I have perform a right shift, it will again become 5 4 5 4. So this is what we have to do, and we have to tell that, is it possible to do this? So obviously it is possible. So we have to tell it is, after performing key operation, our solution is identical or not, or false. If identical, you have to return true, otherwise you have to return false, right? So yeah, so this was much about question. So let's see the approach. So what, so approach is that, so we have to find one observation is that if I am currently, let's say, 1 2 1 2. So if I am performing, let's say, a right operation. So what does it mean? After performing this first right operation, my 1 will come here, right? My 2 will go here, and my 1 will go here. So if I am performing this operation k times, right? Let's say, so my I will, my element which is present at I will go at I plus k, right? and my element at I2 will go at I2 plus k. So basically, it is my zeroth element will go at kth position. My first element will go at 1 plus kth position. My second element will go at 2 plus kth position. Okay, cool. So yeah, this was the observation. And if I am performing the left shift, let's say left shift, so my ith element will go at I minus kth index, right? So there is a case that what will happen if my element is at last. So if like it is 1, 2, 3, 4, if my element is fourth index and I have to, and what I want it to be on the second index, and I'm like assuming that is a one base indexing. So it will be, and my for value case 2, so it will be 4 plus 2 equal to 6, and 6, and now 6 mod 4, which is equals to 2. So it means that I have to shift this element, let's say this is a, to here. If element which is presented 2 will go at 4, right? So I hope this is pretty much clear to you. So so we have to check this side, our old matrix is equal to new matrix or not, right? So what is the case for that? If there's a condition that if my ith index is equals to I plus kth index, if my ith index is equal to I plus kth index, then we can say that our answer is yes for every case. For odd index, sorry, this is for odd index, and for even index, I should be equals to I minus k, right? This, if this is the case satisfies, then we can say that answer is right. But we have to we have to handle some cases that if my I plus k extends the value of n, if these are n number, and if it is extending this n, if we have an element in a row, and if it is extending it, right? So what does it mean? We have to mod it. So what does mod does? Mod will, like, if element will present, let's say if this is the matrix, and if this matrix, if one element is shifted to be here, mod will make it here. Okay, so so I can simply say that my ith element should be equals to I plus kth element for odd, and for even my ith element should be equals to I minus kth element mod n, and n is size of the row. Okay, n or m, n. I hope this is pretty much clear to you. So yeah, this was pretty much the solution. And let's see my code. So code is simple. uh, my mat of I should be equals to I plus k mod m, and mat of ji should be equals to I plus m minus k. Huh. So the thing is, I have added a minus here. So the thing is, let's say if if I equals to, if I do I minus k, and it will, when it will go negative, right? If it is go negative, it is a property of mod, that what we have to do I minus k plus m mod m. Okay, this is a property of a mod. Obviously, also we can also see that, like, if this is the element 0, this is n minus 1 last element, and the second last element is n minus 2, right? So if I am shifting ith element to the last element, it will be equals to I minus n minus 1, right? So it will be equal to I minus n plus 1. Okay, or I minus I plus 1 minus n. Yeah, something like this. So this is I have performed here. I, and for k, k is the it, particular index. Okay, for how much I have to shift, right? So this is the my pretty much approach. If this is not equals to, if my like let's say if my ith element is not equals to I plus kth element, then I will return false. And if there is a case that my ith element is not equals to I minus kth element, then I will return also false. Otherwise, I will return true. Also, I have done, if there is a case, there might be the case that k is given so large. Say k is so large that even value of single k is exceeding, even exceeding the value of k is greater than n. So first of all, we have to reduce the k, and we can reduce the k by k mod n, k equals to k mod n, and this will work. Why this will work? Let's say if I am coming to the second element after performing k operation, if I do mod n and then perform it, I will again come to the second element. If I am coming to the, if I am shifting a and it is coming here, and for some greater value k, and if I do this and perform the same operation, then I also get element here. You can try it by now, try it by yourself, and you can see the solution. Okay, so this was about the problem first, and let's see the problem second. So before I think see the problem second, I will explain you the problem third, because problem second and problem fourth is similar, but about there's a difference of time constant only. So I will just first explain the solution C. Okay. Okay, right. So what the problem is saying that we have given an array, right? We have given an array, and what we can do, what we can do, if there's a condition, if nums of I, this is the array nums, okay? There's a condition, if num of I minus num of j is less than equals to limit, then we can swap it, right? I think, yeah, swap it. Okay. So before observing that condition, first of all, see this. If any array which is not sorted, let's say, and we can swap every element to each other, then we can sort it with using bubble sort, Look, or any sorting algorithm. If there, because we are in bubble sort, I think we do swapping, I guess. Yeah. So as far as I remember, so in bubble sort, we will, if I swap this element with any element, if I swap any element with any element, then I can say that this is fully sortable array, right? Now, now here is the one condition arises in this questions, that num, which is nums of I minus nums of j less than equals to limit. What does this means? That, let's say, take an example. I will show you, explain you with an example. If this is the example, hmm, 1 second. Yeah, hmm. Okay. So this is the case if, now if I first sorted 1, 3, 5, 8, 9, and the for what is the value of k for the bit 2. So k equals to 2. So what does this mean? What does this mean? K equal to 2 says that there is a difference should be if I am swapping two element. If I am swapping two element, then what should be the condition? Then the condition is that the difference should be less than equals to k. I can swap only those element. So there is a constant that I can swap only those element, those two element whose difference is less than equals to k, right? So if I first take this array, this is a I have sorted this array and make this. So if I see what is the difference between here, what is the difference here? So difference is of 2. Here is a difference of 2. Okay, I should have to write it again for clean purpose. So here the difference is 2. Difference is 2. And here the difference is 3. And the difference is 1. So what does this mean? Can I swap this element with this? Yes. Okay. Can I swap element with this with this? Yes. Can I swap this element with this? No. So it means that I can swap these elements with each other. I can swap these elements with each other, but I can't swap these element with this 8, right? So I am not able to swap 8 with any of these number because the difference is going to be greater than 3, right? Greater than 2 because the difference is 3. Can I swap this element with this? Yeah. So what I get from here, I get two groups, 1, 3, 5, and second group is 8, 9, right? So I get two groups, 1, 3, 5, and 8, 9. So now I can only, if I am able to swap these elements, right? If we know that from the first observation that if I am able to swap all this element, it means that I can sort it by any way. So I will able to sort this, and I can only able to sort this part of array, and I can only enable to sort this part of array. So what does it mean? So if 1, 3, 5, what was my array? 1, 3, 1, 5, 3, 8, 9. So 1, 5, 3, 8, 9. Right? 9, 8 or 8, 9? It is 9, 8. Right? 9, 8. So I can sort this part of array and I can sort this part of array. So it will be 1, 3, 5, 8, 9. So yeah, we have sorted this array as much as we can after completing sorting. Let's see another example for better understanding. So if we first sort this array, what we are getting? 1, 6, 1, 1, 1, 1, 2, 1, 1, 2, 6, 7, 18, right? 1, 1, 2, 6, 7, 18. So this is the array, right? And what we have to do, we have to check how much I can sort it, right? And we have to make lexicographically smallest array. What does it mean that we have to like this is the lexicographically smallest, right? This is the lexicographically smallest. As far as I know, this is the lexicographically smallest. So I will try to make this to this, right? So let's see what are the value of first k. The value of k is 3, right? So can I swap this 1 to 1? 1 this one? Yeah, I can swap this. Swap them. Can I swap this 1 from 2? Because yeah, I can swap them because k equals to 3. So difference is 1. Can I swap the 2 or 6? The difference is 4. So I can't swap. So I can swap only this 1, 1, 2 group. So basically I am excluding the group. I am taking the group which I can swap. And can I swap 6 or 7? Yeah, I can swap. Can I swap 7 or 18? No. So there is another group I got 6 and 7. And there a third group I got 18. So I can swap element in this group only. I can swap element in this, all the element in this group only, I can swap the element in all this group. We can't swap the element from the another group. Let this is group 1, group 2, and group 3. I can't swap the element of group 1 with the group 2 because the difference is always going to be greater than equals to k, right? Not equals to, greater than k. So this is our observation. So to make lexicographically smallest array, what is our requirement? Our requirement is that we want that the smallest element should come at top. So what I will do, if this is the array, if this is the array, what I will do, I will swap those element which I can swap obviously. So with this, I can swap this 1 to 1. I can swap this 1 to 1. So I will try to make this group lexicographically small. So how can I make this lexicographically small? 1 will be here, 1 will be here, and 2 will be here. I can't swap them with other elements, right? So I can swap this 6 or 7. I will make them lexicographically smallest. So I will make every group lexicographically smallest, 18. So what I get? 1, 6, 7, 18, 1, and 2. 1 not 12, not it's not 12, 1 or 2, sorry. So this is this array which I got, right? Thickness, I just reduce it a bit. Okay. So this was pretty much about the solution. I hope this is clear to you. So basically, if I summarize what I am doing, so we know that if I have some element in in an array, and we can swap every element with some element, then I can sort it. How? With the use of bubble sort or any sorting algorithm, which requires swapping. Okay. But the thing is, here is the condition. They have given a constraint that we can swap only those elements which have some difference greater than equals to k. So we have divided the array in the groups, right? So I can swap this group. I can sort only this group. I can sort only this group. So to make the string lexicographical, not string, to make an array lexicographical smallest, what I will do, I will try to sort each group individually. If I sort each group individually, what does it mean? For each group which is sortable, what I have done, I have tried to put the smallest element at the last and the largest element of every group at the smallest group at the first and the largest at the min at for and max at last of the group. I hope this is pretty much clear to you. So you can see another examples also. I hope this is clear to you. If this is still confusing to you, you can ask me in the comment section. I will try to make you clear. Okay. So this is my uh, solution. So how I approach this? First I did what I did. First I make a vector, and I have linked every element with their index. I have mapped basically every element with their index and sorted it. Right? Sort it. Now, what I saw, then what I did, if I check if my first element, right, is if I swap my first element with my last element, right, like this is the condition. If I can swap it, then what I did, I just inserted into a set. If I can't swap it, so it means that I am in that case. If I can't swap it, what I did, I just swapped the previous group elements, right? And this was all done, and I just printed the solution. So basically, if I explain you clearly what I did, if this is the so basically I am just trying to make a group. First, if I have what I did, if I can make a group, finding the index of those element. I am finding the index of element whose which of an every group. One second. So my mouse is working. Yeah, it's working. So what is happening here? I am taking that if I can make a group, if I can make a group of my current element to the previous element, I am inserting my current element index because I have to swap those. And yeah, if I'm at that index which is not swappable with the previous, it means that my previous group is formed and I can't add my current element to the previous group, right? I can't add my current element to the previous group. So now what I have done, I have sort, and this is a set basically. So I have stored the index of, so basically I have stored the index of previous group, right? I've stored the index of previous group, and after storing the index of previous group, what I did, I just placed every element to its position. So basically, this is an implementation. Like you can do it by on your own. So basically, the thing is simply is that if I can explain you my implementation with an example. So let's say, so I'm using the last test case to explain you more clearly my implementation. So this is the case. So make it more bigger. Yeah. So let's say this is index 0, this is 1, this is 2, this is 3, this is. Now if I map it and sort them, what I will get? 1, 0, right? And 7, 1, 10, 4, 19, 3, and 28, 2, right? So is this, can I make a group of 1 or 7? What is the value of k? Yeah, what is the value of k? 3. No, I can't make a group of 1 and 7. So this is the integer group. Can I make a group of 7 and 10? Yeah, I can make a group of 7 and 10. Right? So can I make a group of 10 and 19? No. Can I make a group of 19 and 28? Yeah. These are the groups which I can solve. So what I will do, I will, let's say, if my 7th is the first index and my 10th is fourth index. So this is already sorted. 7 and 10 is already sorted. So I will come to third group. So this is single element. This is, so for this is for already sortable. For my third group, as you can see, my 19th is, this is a basically a third group, and I have to sort it, right? So what I did, I have stored this in a set. Set will auto sort them, and at last I got that this is the sorted way of index, and I just store at 2, I just stored 19, and at 3 I just stored index 3, I just stored 28. I hope I'm pretty much clear to you, and if you have any doubt, like, you can ask me in the comment section. So let's see the problem statement B. So yeah, this is the problem statement B. So what does this, the problem says that we have given an string, right? And string contain vowel and consonant. And if string is beautiful, if the string is beautiful if vowels, count of vowel and count of consonant are equals, and the count of vowel into count of consonant multiplication is mod k equals to 0. Like, I hope this is question is pretty much clear to you. Nothing is fancy in this question. So the first part I have solved with the brute force approach. So brute force approach is a simple approach. So simply I just run a for loop on so basically we have to find every substring, right? So I have made every substring with a brute force approach, and for every substring, and I just checked, is uh, is this substring is validating our condition. If this substring is validating our condition, then we have just increase the count and return the count. This is as simple as like simple n squares approach. Nothing fancy here. So yeah, but this is our solution for the second question, right? And let's see now the fourth question. Like fourth question is similar to the second question, but the thing is the constant is higher. Now the case is that I can't run a for loop, like 2D for loop, n square for loop for it, right? Because because it is 10 raised to the power 4, obviously. It will go to 10 raised to the power 8. So we have to think better approach. So let's see the better approach. So let's say this is the string A, B. I'm just taking a random string to explain you. D, E, F, right? I just take a random string, nothing else. So what we want now? So I will think like that. Hey, Varun, what you have done? You have character A. And what you want? You want another character in a whole string such that it follows the condition. So what is the condition? That on that substring, let's say on that substring, count of vowel equals to count of consonant, right? And my vowel into consonant divided by mod k equal to 0. This is the basically condition. So if I try to like think like that way, but what I'm getting that I am not able to get the string which is vowel, which is following this condition, basically following the both condition, right? So we have to think something else, right? So one observation, if you see that A, B, C, A, D, E. So I use a approach which is of a difference approach. So what difference approach does? What I am going to store? I am storing the difference of vowel and consonant. I'm storing the difference of vowel and consonant in a map as a vector. Map of vector. So let's see how I'm storing. So let's say if I come, I will explain why I'm storing it. If I come at A and see what is the count of what is the count like this. So vowel is here is 1 and the consonant 0. So here is 1. If I come here and let's see what is the count of vowel and consonant. What is the difference of vowel and consonant? It will 0. And if I come at C, what is the count of vowel and consonant? It will be 1 vowel and 2 consonant minus 1. And if I come again at A, and if you see from here to where the string is 2 consonant, 2 vowel, 2 consonant, so it means 0, right? And if I come here to so 3 vowel and 2 consonant, it will be 1, and 4 vowel and 2 consonant will be 2, 4 vowel and 3 consonant will be. So this is the pretty much difference I have calculated. So now the thing is why I have calculated this. What is the reason? So if you see this, that let's say if for some index I, if my difference is x, right? What my difference is saying that my vowels are x greater than, my vowels are x greater than my consonant, right? It's saying that. Or and if for another index, let's say j, if my difference again x, what does it mean that my vowels are x greater than c. So if for both index, if for index I and if for index j, if this is the case that my vowels are equally greater than c, it means that my vowels are x greater than c. If in the both case, then what does it mean? And j is obviously is greater than I. So what does it mean that I have I have added some element. I have added the element between them. What I have done, I have added the element between them. Both are equally consonant plus vowel. What does that mean? I've been explaining you again. So let's say if for I my vowel count difference is 3, v minus vowel count difference is 3, and for let's say index 6 my vowel count vowel v difference is for element for index j it is also 3. What does it mean that my vowels are 3 greater than, I have 3 extra vowel than consonant here too, and I have 3 extra vowel than consonant here too. Now for index here I1 I2, what I have done, I have added few consonant and few vowel here, and the amount should be equal, and the vowel count and the consonant count will be equal here. That's why, that is the reason in this region vowel count and consonant count should be equal, obviously, because if we add equal number of vowels in this string and equal number of consonant, our difference remains same. Now this is clear to you. If difference is x and we add equal number of, let's say if I am adding 3 consonant and if I am adding 3 3 vowel, and if I am adding 3 consonant, then again I am also getting differences. So that's why I'm taking difference. I hope this is clear to you why I'm taking difference. Difference is giving that if my initial difference, if my derivative difference at j is equal to difference at I, what does is mean that the string after I and until j have equal number of vowels and consonant. So from this, our first condition is satisfied. And our first condition is satisfied. Clear? Right? So now the first condition is satisfied, and condition is satisfied, and now we have to see the second condition. Now we know that v equal to c. It means that vowels are equal to consonants. So it means that now the second condition is v into c mod k equals to 0. Now count of vowel into count of c mod equal to 0, and we know that count of both are equal to count of v into, now we have to just check if my count of v into v mod k equals to 0 or not. If this is the case, we will increase our count by 1. This approach is clear to you. That is that. Now what I am this, now my approach is going to be, let's say a1 2 3 4 5 6. If I am currently standing at here and my difference is 2 here, 2 here, and my difference is 2 here, my difference is 2 here, and my difference is 2 here. So it means that for this string, so for 1 second, So for this string, we have equal number of consonant and equal number of vowel. So what I'm going to do, when I reach here, I will check if a difference, like how many differences are presented here, and for every difference, I will check what is the value of vowel into vowel divide not k. This is clear to you, and if still if you have any doubts, you can ask me on the comment section. I will try to make it clear, and it will be more clear with my code. So what I just did, I just make a map, right? Int, and to store for every difference, I am storing the index, and if checking if this is the if I'm just checking if my vowel is if I'm getting the current character. So basically, I'm iterating the string, right? And if my character is vowel, I'm just increasing it, and if my character is constant, I'm increasing b. And if I came to this loop and I will imagine, let's say what I just did, let's say I am currently at I equals to 3. What I will do, my map will try to find and my difference is 2. And my difference is 2. My map will try to find is if I have a difference 2 before. If I have a difference 2 before, what I will do, uh, I will I if I have this, I got the index 1, and I just did 3 minus 1 divide by 2. Divide by 2. So what does it mean? So 3 minus 1 gave me the number of elements between my previous element, right? And I just divide by 2 just to get the count of vowel. And we know that the count of vowel equal to a count of consonant, and we just check the given condition. And if this is the case, I just increase the solution, and I just post my current index into map. I hope it is pretty much clear to you. If you have still any doubt, you can ask me in the comment section. Thank you for watching this. Until here.